So hello friends, I am Neeraj. In this session, we'll be talking about slices in much more detail. Because believe me, slices are much more powerful over arrays, and that is why this is the reason why most of the time we use slices over arrays. So slices, we in the previous session we have already talked about like how we can create slice and what are the basic operations that we can do upon slices. So in this session we will be talking about two or three more. Basically, they are more major concepts, and that makes our slices much more powerful. So first of all, like let us understand what is this capacity and how it can keeps on growing. So right now, if we try to run this program as it is, so the length is total 5 because we have assigned it that way. The length is 5, and declared it with the initial capacity of 6. So what if we append a new element into our slice? So let's say we added 10, and now if we try to run this application, so again the length is 6 and capacity is also 6. Reason being, because previously the length was 5, however still there was the total capacity of this slice was 6. So still there was one element, one space left which can be accommodated into this slice. So that is why right now we added one element, and right now the length has also become 6 and capacity has also become 6. But if we try to add one more element into this slice, let's say I added 12, and now if we try to run this program, so see what happens. So length has become 7. Reason being, previously we added numbered value 10 to this slice, so the length became 6, and again this time also we added value 12 to our slice, so length becomes 6, but the capacity has got increased double of the previous capacity. So you so just give attention over here at this line number, that previously we have defined the maximum capacity of this slice was defined as capacity of 6, and until it was and we kept on adding the elements. So up to this line, so when we tried to add the value 10, so it was beyond the capacity, so that is why there was no change with the capacity. But the moment we added one more element beyond the initial capacity, so what it did is, our Go compiler did is that it reserved that much of the double of the previous capacity. So do remember, previously the capacity was 6. So right now when the new element beyond the capacity got added, so just for the future's perspective, so it tries to accommodate whatever the double of the capacity, whatever previously declared. So this is the one very important concept with the slices. And secondly, there is one more thing that we can right now we have added like sequentially. So but we can also add more values with one go. Okay, just like this. So this is also pretty valid, and many times we keep on doing that way also. So yes, so all the elements, so basically this is a variadic function. So when we talk about that one, so definitely we will come across about functions and other stuffs. So but for now, so keep on just think of it that we can pass on the multiple elements in one single go. And not only this, rather we can also provide add slice as a parameter like this. Let's say 1 and 2, and here we can append, while we are trying to append a new element to our slice, so we can pass on the previous slice with 3 dots. So 3 dots refers to that whatever the values, it is you can think of it something like destructuring, that kind of thing. So whatever the element that is in this slice, so that will be added into this this append. So it can take we can pass on the argument in the append method. So okay, so 1 and 2 were also added, and With working with slices, one needs to be careful for one single thing, that for example, say we created this way, we created an empty slice, and if we try to add something like we cannot write something like y1 or let's say y0 equal to 1, because that is basically beyond the limit, and so that could result an error. So let us try to run it. So yes, so error is there, but reason being that with this statement, with this line, we have initialized an empty slice, so there is no index. So if we try to print the actual length also, so it should be 0 0. So let us try to change it, let's say y, and here also change to y, and here also y. And now if we try to run our program, so basically, so let me move this line here, and now if we try to run it, so basically capacity length is also 0 and capacity is also 0. So we cannot add element into an empty slice by using the indexes. Rather, all we have to do is we have to use the append method. So basically, working with slices, append is more handy, and most of the time we use append. And let me comment it out first, and now if we try to run it, so this is perfectly fine. And we can also do, once the element has been added to the slice, and now we can actually change the index just like a regular way. Okay, so something similar. So yes, so previously it was 10, we added the value 10, and later on, so at the 0th index we are changing the value from 10 to 1. So this is actually perfectly fine. So that's all for this session. So these were the major concepts and very important concepts about slices. So these are the things which makes our slices much more powerful. And one last thing which I forgot, so that is also a very important thing, just for the sake of your understanding about how this is happening. So if we run it this way, so previously, so we created a slice here, and we are appending multiple values, let's say 13 and let's say 14, like this, and the initial size is capacity is 6. Now if we try to run it, so actually the size capacity got increased, just the double of the previous one that we already talked about. So internally what is happening here is, as for example, say in memory, so this is our memory, let's say for example this is our memory, and here say the Z started from this index, this address. So when we wrote it something like this, so Z came on here, and initially let's say 1, 2, 3, 4, 5 and 6. So all this memory blocks got reserved for this Z slice, and the moment our compiler encountered to this one, so right now the capacity was 6, and we added beyond the capacity, initial capacity, and now the next capacity would be like 12, so it would be double of the previous capacity. So internally what it does is that it will copy this whole memory blocks from here, and it will find a new memory empty space in our memory, so that our 12 memory addresses can be accommodated, because slices and arrays, they are stored in contiguous locations. So it might happen that after this address, so there are some different variables, so that way it won't find a contiguous memory blocks. So that is why it copies this whole thing, and it will create a new, it will find a new memory block with a capacity of 12 memory blocks, and it will copy this this whole object into this one, and the new address of that z variable. So right now the z would start pointing instead of this one to this one. So this is what internally happens in our memory. And also one more thing I would like to explain here is that initially the array, and it is applicable for both arrays and slices. So initially the z this variable, the array or slice refers to, that is only having the address of the 0th location. And when we say that, for example, say when we try to access, let's say 0 and number 2 and the 12 and the second index, so what it does is that it has the address of the 0th index, and in order to get the value of the z index of second element, so it keeps on, it is 0, it is 1, it is 2. So it will add 2 into the 0. So that is why, so this is how the this will actually add the more index from the 0th address. So this is 0, 1 and 2. So we have to find the value upon this address, right? So what it will do is it will add 2 from the 0th, from the base address. So first address would be this, second address would be this. So this is how the value would be returned when we write this statement. So it will come here at the 0th location, and it will add the 2 memory blocks from the current address. So finally this value would be returned into this. So this was something, actually this is more of the theoretical, like what is happening inside our memory, but yes, I thought it's better to understand. And from the next session, so we will keep on, we will move towards the few more data structures like maps and structs. So they are also very powerful. So stay tuned, and that's all for this session. So I will see you in the next session.